So diffraction is very simply the spreading of waves as they pass through a gap. So that's your fundamental idea of diffraction. As wave passes through a gap, it will spread out. Key thing, when do we get maximum diffraction? Well, we want a wavelength that is of a similar order to the size of the gap. So if you've got a wavelength and a gap, they're of a similar order, you will maximise your diffraction. If they're significantly different, they're many orders of magnitude different, then you will get no diffraction and it will approximately travel straight through with no spreading at all. So for diffraction, in this example, we're just going to look what happens with our single slit. We've got a single slit, the wave's coming in this direction, and we've got a screen along the back. And what we see directly opposite the slit is we get a maxima. This maxima will be the most intense, and as we go away from it, it will decay like so. And what we see is we see a similar pattern on the other side. So the intensity will be highest in the first maxima, then decrease to the second, and so on. So you get decreasing intensity as we go further away from the centre. The other key thing, this central maxima will actually be twice as wide as all the other maxima. The key equation for this is knowing, well, what is the width of the central fringe. To get a nice equation for this, so the width is just going to be 2 lambda d over a. So in this case, w, as we said, is the width of our single fringe. D is the distance from slit to screen. And A is our aperture width, so in this case, the width of the single slit.